So last time we left it here, like we printed the summary of the model, but we will be picking up right from there. And now we can also print the layers, from the model. Then how to do that? To do that, you need to run a for loop over the model.layers, and you can print the layer name. This will also return you the same thing, which we can see over here in the table, but this is the full detail, all the detail about all of the layers, but this contain only the names of all of the layers, as you can see over here. So it's like quite similar to that. And the next step would be to read the data from the disk. How to read the data from the disk? There are multiple ways to read the data from the disk, but in this example, we will take the help of TensorFlow or Keras, TensorFlow.Keras. In its pre-processing module, we have a module image. From there, we will import image data generator. It will create the images in the form of a generator. Generator is something which will return the image one by one to the program, whatever it would be calling. So first we need to create a separator generator of object for training data and testing data, and image data generator. Here I would be adding, I would like to add one feature over here, which would convert all of the images to all of the pixel values to float, and will then divide each of the pixel value by 255, which means this will convert the image to double. Rescale is equal to 1.0. 255 will convert the image to double type. And what is double type? Double type has the pixel value between 0 and 1. So the maximum value of a pixel is 255 in one plane of the image. So dividing by 255 will always, this is the maximum value of a pixel, of a maximum possible value of a pixel. So this will basically scale all of the values between the scale of 0 and 1. So it will become easier for the neural network to work with. Actually, it will shorten the memory requirement for the computation, so that's why we use it. And the same thing would be used for the test generator as well. And now we can start reading the training set from the disk. Our train set. We have three kinds of train sets. Let me show you first. We have these three train sets. One is made up of 25 images in each of the category. Another one is made up of 100 images in each of the class or category. And the third one is made up of 4,000 images in each of the class. So this one will eventually create 25 images in each of the class, and we have two classes. So total of the 50 images would be there, and 200 images in this one, and 8,000 images in this one. In our test set, we are having 15 images in each of the class, and the total of the images in the test set would be 30 in both of the classes. I have also collected their stats over here. So over here you can check that this is 25, training set 25. It has 25 cat images, 25 dog images, and total of the 50 images. And training set 100 will contain 100 images in each of the class and total of 200 images. Training set all will contain 4,000 images in each of the class and total of 8,000 images. And test set contains 15 images in each of the class and 30 of the total images. So now we will get back to our program and we will start reading the data. So first, the training set, for the training set, we will read it from here, from this particular directory, train set 25, and the test set would be like, we will read the test set from here in all of the scenarios we will cover within this video. So let's go with the train set first. In order to read the train set, first we need to call this generator, which we have created up there. And from there, we are having a program built in within this generator, which is called flow from directory. Like this will read all of the flow, like all of the images from a directory. So here we need to enter tiny data set, and then we can enter our training set 25 folder name. And this will basically read all of the images from there. And if you remember, up here we can see that our input shape for each of the images 64 by 64 by 3. But in our directories, our images are not so consistent, so they are having different sizes. So if you will see this image, so this image is 300 by 280. And in the contrary, if you will see this image has a pixel size of 448 into 258. So they are not consistent, like each and every image is of different size. In dogs, if you will check any of the random image, you will find its size, which is not in the particular pattern. So this is again 272 into 335. But we are expected to enter the value size, the standard image size of 64 by 64. So we will need to manage that over here. So in order to do that, you can do target size is equal to 64 by 64. And this will take care of the image size. Now batch size, like how many images would we read in one time? It would be 32. Class mode would be binary because we are having only 2 classes, so it would be binary. And then shuffle. I don't want to shuffle the images each time we will read them from the directory. So I'm basically putting it to false. So this is our training gen. What's the problem? Okay, target size. So this E is missing from here and something is missing from the class model. It's not class model, it's class mode actually. Sorry for the typo. Yeah, now it's done. Let's copy it here and bring it here and do the same with test set as well. And here we need to change the name of the test set from the training set to test set. And else everything would be pretty much same, so we don't need to make any change. It's done. So as you can see from this 25 image data set, we have read total 50 images in 2 classes, and from here we have read 30 images in 2 classes. Now you might be interested in viewing the classes, like which class is which at which index which class is read actually here. So view the classes and class labels. So what I am trying to say is this. Might be you want to see the class of each of the object which is read over here. We have read 50 objects over here or 50 images over here. Out of those 50 images, 25 of those are basically 0 and 20 and the remaining 25 are 1. Now what is 0 and what is 1? In order to get that, you need to do class indices here. So this will basically return you the labels which are read within this particular set. So this says 0 is for cats and 1 is for dogs. So now going next, now we need to, we can train our model right away on the data, but now there's a problem. But let's try straight away and then we will hit the block or hit the problem and then we will gonna resolve that. So train set and epoch. Now this set the epoch to 2. What is epoch? Epoch is a fancy name which is equal to iteration or rounds or so. Or we also use iter as the short of iteration. So I will prefer to use this iter or round, right? I don't use this epoch name so much. So, but this will basically generate an error. Oh, not this one. We need to write epochs here, not epoch. So this is saying you must compile a model before training and testing. But this model isn't compiled yet because we haven't entered any of the optimizer yet. So first we need to import an optimizer, and then we can do this kind of calculation, like then we can fit our model. So to import the optimizer, we will again make use of TensorFlow. Adam. So Adam is one of the standard optimizer which is used over here. Now let's create an object for Adam. You can name it Adam or anything else, and let's keep the learning rate 0.001. This is to control the learning or control the gradient. Then run this. Oh, just a moment. Oh yeah, I haven't compiled it yet again. So model compile optimizer is equal to Adam. Note, we haven't entered this thing, but we have entered this thing, but you can also enter this thing straight away. You don't need to create it here, but this way it becomes more manageable. So I love this way. And then it comes to loss. So the loss would be loss or error, or the prediction error would be managed with cross entropy. Cross entropy is one of the metric which is used to compute the loss or error. And this binary value says that this will be basically, we will be computing the cross entropy for only 2 classes. So it's telling us that way. And then the metric, like on the basis of which metric we want to do the analysis of the performance. So the performance analysis would be done on the basis of accuracy in this particular example. Okay, so here, see, I have kept only 2 iters, but we can keep it to 10 iters, 20 iters on the basis of our requirement. But I'm just trying to keep it concise, so it's just 1 iter. So I will now run the model evaluate generator, and we can pass it train set. So now, from this model, the output of this model, what we can get that this much is the total loss, and this much is the accuracy which we have got from this particular iter or this particular epoch. In this iter, if you note, the accuracy goes up and the loss goes down. So this is what will happen if you will increase the epochs, but this is not necessary. This is not a have to trend, like this won't surely happen. So the accuracy may go down as well. But yeah, there are multiple factors which actually works behind this thing. We will come to those, might be in the later parts of this series, or in a different series might be, I'm not sure yet. And the result is this. Now here, this is accuracy, and this is called loss. This is the training loss, and this is the training accuracy. And if we are not interested in the loss here, so we don't want to get the loss, but in this list, we are getting 2 values. So we can simply make use of the second value. We want to get only the second value, which stands for accuracy. So that would be okay for us. So then the result 2 would be applied on test set here. So when we will apply it on the test set, now let's see how this will behave. This is also like giving us 50% of the accuracy here. Now let's try it with the change database. Like now we will change our database to 100 images, where we are having 100 images in each of the class, as I have shown you up here, that we are having this data set, which has 100 images in each of the class and total of 200 images. So let's go with this. Let's read this and then come over here, train the model again, and test the model again. Now the training accuracy has gone up by slight percentage, only 0.5%. Let's check about the test. So test set hasn't gone up. There's no change in this test set. This happens because it's not necessary that with the increase of the data set, you will be like able to increase the accuracy, but in most of the cases, you will definitely would be. But there is basically a factor which works behind this, that the data set which you are giving to the neural network must be like containing the pattern which are matching with the test set images. So here I am sure that the data set which is containing all of the images, like which is containing 8K or so images, that basically covers most of the patterns which a cat or dog can have. So we can try our model with that one as well, and then we can check that how the accuracy would be impacted. And as you can see that the accuracy is being like impacted over here severely, like it's going up. It's going up. It's not severely impacted. It's betterly impacted actually. So it's going up, and but it's stuck at 59 or so. But with each and every iteration within an epoch, like this is going up. And let's check how this will behave at the end. So we are almost like going to get done with the second epoch, and after that we will check our train and test set, and then we will evaluate the accuracy again. Let it finish. Yeah, it's finished. So now our training accuracy is boosted to what percentage? Let's wait for the result. Oh, it's taking longer. It's 71%, 71.37 to be precise. And here, this accuracy is boosted to 63%, which is a good sign for us. So now we can do some of the hyperparameter tuning or so, but that would be covered in the next parts. And this is how like the data, the volume of the data actually impacts the performance of your classification model. But this doesn't essentially mean, as I have told you, that increasing the data doesn't essentially mean that you will be able to increase the accuracy. But in most of the cases, when your training data will be able to able to contain all of the patterns which would be included somewhere within the testing data, so that would be the best data, and that will definitely gonna boost your accuracy. So let's see you in the next video. This is for this particular part. So thank you guys.